Hello everyone, hi, good evening people. I welcome you all to the platform of Sri Chaitanya. My name is Shubhajit everyone, and today we are here for this session which is an score session everyone. As you all people know that we are here for making you all prepared for the score examination. Following that only, we have completed one of the previous sessions, okay, where we have encountered a lot of different types of questions related to the grade 9 and grade 10 of physics. Today also we will be trying to complete few of the questions, okay, which may be this may be the type of the question that may come in your examination people, okay, score examination, okay, fine. So there will be a lot of different questions related to all the chapters that we are having in the grade 9 physics. Okay, let us begin and let us understand few of the questions over here people. Okay, so here comes our first question, and I request you all to please let me know the answer for this following. Okay, so let me give you a timer of 1 minute people. If it will be, please, what will be the answer for the following? What do you think? What do you believe? Two bodies of a different masses, M1 and M2 are there. Okay, how to solve this type of questions? Yes, people, what do you think? What will be the answer for this following question? Okay, let us solve this. Okay, it is a very simple question. Okay, like two bodies of different masses, that is M1, MA and MB, okay, are dropped from the two different heights, A and B. The ratio of the time taken by the two bodies to drop through this distance is. So it is a very simple question. Let us try to figure out something. Okay. As we all people can understand, there are two different bodies which is trying to come to the ground. This is what it is there. Fine. They are doing their best to reach to the ground, and the bodies are being thrown from the two different heights. This is one of the body. For an example, it will be having a mass MA. Okay, and the other body which is having the mass MB. Fine. Now, when this particular body is trying to reach down, the height, let us suppose the height is going to be A, and for this body, let us suppose the height is going to be B. Now, in both the cases, as you can understand, both the cases, these masses are being released from their height, according to their height only. But in every single case, if we try to understand, the initial velocity of the body A will be equals to 0, and over here also the initial velocity of the body B will be also equals to 0. Fine, both the cases are there. Now what we have to find out over here is we have to find out the ratios between their time taken. Okay, the ratios between their time taken. Let us say this, for body A it is TA, and for body B it is TB. We'll use the second equation of motion, if you can understand from here. So the solution for this is, we will be using second equation of motion. For your revision, second equation of motion is S equals to UT plus half. Now, as you people can understand, this is under the gravity. So instead of writing A, we will be writing G. Okay, and we all people know that the acceleration due to gravity having the direction downwards, and these two bodies are also coming downwards only. These two bodies are also coming downwards. So they are having the similar direction as the direction of the acceleration due to gravity. So we will be taking the value of G as positive. Okay, so G T square. Fine. This is the actual formula for the second equation of motion due to the gravity. If we talk about the body A, for body A, everyone, and if we talk about the body A, what we can write? We can write in the place of S, we can write A will be equals to U T plus half G t square. Simple. Okay, as you people can understand, the value of ua, of initial velocity of a body a, it is equals to 0. So a will be equals to half g t square. Simple. Fine. Now we are totally interested in the value of this TA. So we can write from here, what we can write is, we can write that the TA square will be equals to 2a by g. 2a by g, that is the TA square. Fine. Similarly, we will be finding the value for the b. For the body b, we can write what? That is the height b will be equals to ub tb plus half, it is for ut plus half gt square. So g t of body b, so you can say it is going to be 0 again. B will be equals to half g t square, everyone. So again, for the time for the body b, we can write it down, that is 2b by g. So we have got an understanding of two different times, that is for the body a and for the body b. We want to find their ratios over here. So what we can do is, we can find out that ta square by tb square can be written as like this. It can be written as 2a by g by 2b by g. As you can understand from here, the simple mathematics, this g and this g is cancelled out. We are having 2a, and this 2 and this 2 is cancelled out. We are getting what we are getting. We are getting ta by tb can be written as under root, or you can say whole under root of a by b. In short, we can write it down. What we can write it down? We can write it down. The ratio of time of body A is to time of body B. Body A is to time of body B can be, that is root A is to root B. I hope you have understood this much. Okay, this will be the option. Yes, very good people. Okay, that is option A. Fantastic. Option is the correct answer for this following. I believe you might have understood that entire solution, how to find it out. Okay. Now, let us move to the second question, which is going to be this. Fine. Chalo. So I'll just provide you 1 minute of time to read, to analyze, to find out the answer, whatever that answer is going to be according to you, which is going to be correct. Time of flight is independent of mass. Very good, very good, very good, very good. Yes, it is independent of mass. Very good. It is independent of mass. It totally depends on what? It totally depends on what? Time of flight depends on what? There are two variations of time of flight that can be dependent on. One is the initial velocity, second is the height. Okay, you have to just go through the formulas. Okay, normally we go with the time of flight where it totally depends on the initial velocity, but in our cases the initial velocity was 0, so we have to switch to the height. Fine. Chalo, what do you think? What will be the answer for this? Okay, let us solve this thing. Again, the solution for this particular question, people. Again, it is a very simple question. You don't have to think that much. A balloon of a mass 1000 kg. Okay, so we can write it over here as K. A balloon of a mass 1000 kg is floating at the sum of the height. Fine, we don't know the height. Okay. If 100 kg is taken out from it, we are saying 1. Okay, no problem. If the 100 kg of the mass is released, you means it has been gone. Okay, that means we are having the net mass is 900. Simple. Okay, we are having the net mass as 900. Okay, so the acceleration of the balloon will be what? Okay, so now it is a very simple thing. As we people know that the force will be equals to mass into acceleration. Simple word. This force can be written as net force will be equals to mass and the acceleration, everyone. So what is the net mass that we are having? Or you can say it right like this. the net mass of the entire system and acceleration. Okay, mass is fixed, we cannot write net. Okay, so overall mass that we are having, so F net can be written as mass into acceleration due to gravity, mass of the balloon, which is left it out, into acceleration due to gravity, will be equals to ma. Fine, so you can write it out over here. Is how we can go with this. We do have the weight, right? Yes, so mass is going to be, we can cancel out the weight also. What? We cannot write 9.8, right? No, we cannot write it down. We cannot write it down. We cannot write it down, of course, because it is going to be 9,000 will be equals to 900 multiplication of the acceleration. Now the acceleration is coming out to be, because we have to take the value of g as 10, so it is going to be 9,000 divided by 900. It is going to be 1.1. It is going to be 1.1. No, it is going to be 10 only. It is going to be 10 meter per second square. Is there any mistake that I have done over here? 10 meter per second square. What do you believe? Option A. The acceleration of a ball we have from balloon. So 900 multiplication of the acceleration due to gravity. As I have done certain wrong in this, I don't know what, but let me solve it again. Okay, so we have the mass of the balloon, which is given as 1000 kg. Fine. Okay, and we have release, so mass of the released air, it is going to be 100 kg. Fine. So the total mass, I can find it out, that is 1000 minus 900, 1000 minus 100, which is going to be 900, which is going to be 900 kg. Fine. Now if it is so, what we have to find? We have to find out the acceleration, right? Fine. If it is so, we can go with few things over here. So the mass is given to you, we have to find out the acceleration. We need and force, because we know the F equals to ma. Here we have to put 900 acceleration, but we have to put something over here, that is F. If we are going to put something which is going to be air F, again the value of A is coming out to be 10. What is the problem value? F minus mg. What is the problem? F minus mg. So what will be the force then? What will be the force then? F minus mg. Very good. Okay. What will be the value of F over here? What will be the value of F over here? Come on, tell me now. What will be the value of the F? Anyone? Come on, people. What is the mistake that I am doing? What is the mistake that I am doing? Come on. Say something. You people are participating over here also. Tell me, what is the mistake that I'm doing? Come on, what is the mistake that I am doing, people? What is the mistake that I'm doing? F is 1000, good. And then, yes, okay, very good. So basically, when we write F equals to MA, we write F net for this. Getting my point? So F net, we are having the total mass that is 1000 kg. So the F is coming out to be 1000 minus the mg that has been released. That is going to be 900 from here. Sorry, 9. You can write it down from here also. What do you say? F is 1000. What will be the mg then? Mass is 100. Okay. What else? F equals to 1000. Are say something? What will be happening? Come on. It will be 900, right? Will be equals to mass, that is 900 again. Will be acceleration. Okay, so here we can find it out. That is, it is going to be 100, which is equals to. Sorry. We are having 1000 or what? We are at 1000. So 4 zeros minus 100 is gone, right? So we are having 9000 will be equals to 900 acceleration. It is 1000 will be equals to 900 A. The value of A is coming out to be 1000 divided by 900. This and this is cancelled out. If you try to solve this thing, I believe it is coming out to be 1.1 meter per second square. That is fine. This is how it is really done. People, let me calculate it first. I believe it is 10, 9 ones are 9, 9. Again, it is 1.01. It is what, that is what. So this is going to be the correct answer, everyone. And it will be upwards. Please do remember, it will be upwards. So from the second law, we know F net is equals to mass into acceleration, people. Balloon is floating, so means upward force of the balloon will be wages 1000 0. Very good. Okay. So when we talk about the what will be the actual weight that is floating over here, that is 1000 minus 900, 9000. So actual that is releasing, that is forcing downwards, that is going to be this. And you, if you are going to solve this thing, you will be getting 1.1. Okay. I hope it is clear to all. Okay. Is this much is clear to all people? Please say yes or no. Please say something. Is this much is clear to all? This much is clear to all? Settle. How you have a route? And why not? It will be because we have to take the value of G as 10. Na? The total mass of this body is going to be this much 1000. Okay, and where the 100 kg is been released downwards, equal and opposite. That is what it is there. So what is the net mass that is there in the body? The net mass is what? How much the net mass is there? What will be the net mass which is there on the body? That is what it is there. See, 1000. Solved it. Acceleration. Fine. Fine. 9,000. Oh my God. Okay, no problem, sir. I am Shri Chaitanya, student super certificate program with the fine. Okay, no problem. Let me solve this thing in a different way then. Okay. For your understanding, people, for your understanding, just okay. Maybe it is a confusing question. No problem. Let us solve this thing. We know the mass of the balloon is given as 1000 kg. Fine. Got it? If I want to find out the weight of this particular balloon, which is at the initial point, I will be writing 1000 into 10, that is going to be 10,000, right? It is written over there, Newton, if I'm not wrong. As you can see from here, it is written the value of G is 10. Fine, no problem. Moving next. So 1000, this, it has been clear. Fine. After that, what is happening? After that, what is happening? The 100 kg of mass has been released. After that, what is happening? The 100 kg of mass is being released. Fine, no problem. If 100 kg of the mass, if the 100 kg of mass is been released, so what we can find it out of from here is, fine. So what will be the final mass then in this particular case? So when the 100 kg of mass has been released, so M final, we have to find out the M final. So let us talk about like this way, na? So 100 kg of mass has been released. So we are getting the mass final mass. It is going to be 900 kgs. 900 kgs. So weight at the final point then, weight at the final will be over what? 900 multiplication of 10, that is going to be 9,000. 9,000 what? 9,000 Newton. This is what it is going to be. Fine, 9,000 Newton. If it is 9,000 Newton, after that what is going to happen is, we have to find out the F net. What is the value of F net which is acting on this particular body? Fine. So let us find out the value of F net which is acting on this. So the weight is also considered to be net only. So if we want to find out the value of F net, see. One of the mass, when we talk about the weight of the body, it is like this, getting downwards. Fine. And when it is getting downwards, the body is moving forward upward. Okay. So we can say the buoyant force is acting on it. So what will be the value of buoyant force over here also? What will be the value of the buoyant force which is acting on this particular body? What will be the value of the buoyant force which is acting on this? What will be? See everyone. This is the mass of the body, the weight of the body initially, which is acting on that. So it will be third equation of motion, equal and opposite. So it will be considered to be the force at the buoyant, everyone, which will be the same 1000 Newton. There will be no any 1000 kg, na? 10,000, which is there will be no any changes, equal and opposite. That is what it is there. Fine. When we talk about the F net, what we can write it over here is, we can write it down. This thing, that is the buoyant force which is acting downwards, minus this thing W, the weight of the final body which is there, weight of the final body. So F net can be written as this thing, 10,000 minus 9,000. So F net is getting out to be 1,000. This is what it is there. We know from the second law, F net will be equals to mass into mass final into acceleration. F net is equals to 1000, will be equals to mass, that is 900, acceleration A. The value of A is coming out to be 1000 divided by 900. It is going to be 1.1 meter per second square. Simple. Here of the buoyancy equals to the weight only. Balloon is floated. That is what it is saying now. What is the initial value? What is the initial value of the mass of the body? That is 1000. Getting my point? So if I talk about the buoyancy, so body, if the something is floating, getting my point? So the mass and the buoyant force will be equal, na? Mass, the weight of the body and the buoyant force is equal. That is what it is then. So it is floating. That is what I am saying, na? And what is the final mass? Final mass is 900. Because 100 mass is 100 kg has been released from it. This is how it been solved. Fine. Chalo. I believe we have We have done a lot of, we have spent a lot of time in this. Please, I request you all to solve this particular question, people. I request you all to please solve this. I request you all to please solve this particular question. Understands? Thank you very much. I believe, okay, see, we have a limited time over here. I might have taken a lot of things to make you understand about this, but we have to do it. I cannot say no to your this also. Consider there are two spherical planets of the same average density. Planet 2 is 8 times the planet 1 in the terms of a masses, massive. So masses means mass is also been grown. Fine. So if it is mass, see, I'm saying this is one of the planet and this is another planet. This is first planet, this is second planet, and it has been said that the second planet, it is 8 times the first planet. The second planet is 8 times the first planet. Now, if it is so, what are the things that is going to be changed? First of all, the radius, obviously, the radius is going to be changed. The mass is going to be changed. Getting my point? So, we'll talk about this in this particular case. So, when we talk about this, if it is 8 times, we can say that the mass of the planet 2 will be 8 times the mass of the planet 1. Fine, no problem. Next, the ratio of the acceleration due to gravity on the surface of the second planet to that of the first planet. What we have to find out? We have to find out the acceleration of the gravity of the surface of the second planet. We have to find out G2 divided by G1. Fine. We have found out the difference between the masses. Let us find out the difference between the D. You are saying 8 times. Are you sure? Good. Let us so. Okay, let us find out the value of the R, everyone. Okay, let us find out the value of the R. If we are going to find out the value of the R, everyone, see, we know one formula, very simple formula it is, that density will be equals to mass per unit volume. Okay, that is what we know. If we want to find out the value of the, if we are going to find out the value of this particular masses, then what we can write it over here is, we can write it over here. For this, we can write it that M2 can be written as density. Density will be constant, I believe. Density is constant because there are two different planets. Size may be bigger. Fine. Density multiplication of the volume, density 2 multiplication of planet 2 will be equals to 8 times the density of 1 multiplication of planet 1. Volume of 1. Okay, that is what it is there. If it is so, when we talk about the density of 2 multiplication of the volume, everyone, so it is 4 by 3 pi r2 cube will be equals to 8 times density of 1 volume, that is again 4 by 3 multiplication of pi r1 cube. Simple words. Now, what we can understand from here is, what we can understand from here is option B, option D or option B. No problem. Okay, we can say the density of 1 will be equals to density of 2 because density is not changed. Okay, if it is so, what we can find it out over here is key, this and this is cancelled out. We can say 4 by 3 pi r square cube will be equals to 8 times 4 by 3 pi r1 cube. Now this 4 by 3 cancel, this pi is cancelled. Okay, what we are getting over here is, we are getting that the r2 cube by r1 cube is equals to 8. Okay, if it is so, we can say that the r2 by r1 is equals to cube root of 2 with cube root of 8, which is going to be 2. Simple. Fine. If we have found out this much, okay, now we will be moving forward with the value of G. As we people know that the value of acceleration due to gravity is gravitational constant, mass of the bigger body divided by the distance between them, that is the r. Fine, that is what it is there also. Let us talk about this. So let us suppose that is g2. We can write g, which is constant, mass of the body 2 divided by radius of the body 2. It is square. Fine, that is what it is there. Divided by, this is whole divided by g1, which can be written as g m1 divided by r1 square. This is what it is there. Now as you can put over here, there are a lot of things that we can cancel out from this. So what are those things? This g and these cancel out. This m2, see, this m2 can be written as, instead of writing this m2, I can write 8 times of m1. Fine, so this m1 is cancelled out. Now what we can say over here is that the g2 divided by g1 can be written as 8 by r2 square multiplication of r1 square divided by 1. Fine. It is r2, Rohit, sorry. It is r2. If it is so, g2 divided by g1 can be written as this r2 square. So r2 by r1, let us talk about like this way. We can talk about this like this way. How? We can say that the r1 square by r2 square multiplication of 8 by 1. Fine. If it is so, we have to find out what? We have to find out the acceleration due to gravity. Na? If it is so, fine, it is 2:1, so it will be reciprocal of this. We can find it out. G2 by G1 can be written as R1 by R2, or R2 by R1, it is given as 2, so it will be squared. If it is getting squared, I can write 1 by 4. 1 by 4 multiplication of 8. This and this is cancelled out, that is 2. So G2 by G1 is equals to 2, or we can say G2 is to G1 will be equals to 2:1. 2:1 or 2, whatever. Option B, everyone. I hope that math is clear to you and you have understood this much. Fine. Chalo. If it is so, then it is very much good. Let us move forward, everyone. Moving to the next one. I believe I have done no any mistake in this. But yeah, sometimes mistakes happen. What do you think about this? What do people think about this question? What do you people think about this question? See, if the displacement of the particle is 0, then what we can say about the distance? See, for an example, if the body is moving in a circular path and the initial and the final positions are same, for an example, initial and the final positions are same, this is the condition where displacement is going to be 0. That is true. But when we talk about the distance, it is going to be 2 pi r, that is the circumference of the circle. Fine. That is the first case. Second case is, suppose that the body haven't started yet. It is not moving only. Because displacement is 0, we cannot say no, the body is moving or not moving. So that is the second case. If the body is not moving, in that particular case, the displacement will be equals to all 0 and the distance is also 0. So we cannot say, in this particular question, we cannot say that what is happening with the body. We should know what is happening with the body. The body is moving or not. So there are two conditions, okay. According to the two conditions, it's not been written that it must be 0. We cannot say this because it cannot be 0 also. It cannot be 0. It must be 0. How it is happening? It positive, we cannot say. We have to understand what is happening with the body, whether the body is moving or not. So that is maybe 0, may not be 0. Fine. Moving to the next question, which is this, please. Solution for this, people. If a train is traveling 72 km/h to be brought to rest, okay, in distance of 200 meters, then the magnitude of magnitude of retardation will be what? So we have the value of u, that is 72 kilometers. Sorry, we are having 72 kilometers per hour. We have to convert this thing into meter per second, that is 72 multiplication of 5 by 18. I believe this shortcut you know. This and this, it is going to be 4 times, it is going to be 20 meter per second. Fine. Final velocity is going to be 0 because as you can see, it has been brought to rest. When we talk about the when we talk about the distance, s is equals to 200 meters. Fine. What we have to find? We have to find out the retardation. Okay. We have to find out the retardation. Obviously, the answer is going to come in negative, people. So if we try to solve this thing, we have u, we have s, we have to find a. So we can use the third equation of motion, that is v square minus u square will be equals to 2as, everyone. If you try to solve this thing, v will be equals to 0 minus initial velocity is 20 square will be equals to 2 multiplication of a that we have to find, multiplication of the s, that is 200. It is negative 400 will be equals to 400a. So here you can see the value of a is coming out to be negative 1. Negative 1 meter per second square. Okay, this negative sign will be giving you an idea that it is retarding. It is retarding basically. Fine. It is retarding, so the option will be D. Simple. To the formula questionnaire first, na? To the point. What do you think about this? Again, it is a very simple question. Why to take time in this solution, people? Now we have to find out the speed is given to us. A ball is thrown up, so initial velocity is given to us, that is 19.6 meters per second. What else? The maximum height we have to find out the value of h max will be what? We know at reaching to the value of h max, the final velocity will be equals to 0. We have to value of g will be taken as, let us take, it is g will be taken as negative 9.8 meter per second square. Why it is negative? Because our body is going up, acceleration due to gravity direction is downward. According to our body, it is opposite to the direction of the body, so that is why it is negative. So u, v, g, what we have to find? We have to find out the h. Again, what we can find out? Say in third equation of motion, everyone, v square minus u square will be equals to 2gs. In the place of s. Okay, so v square it equals to 0, u value is 19.6 whole square will be equals to 2. The value of g is how much? That is negative of 9.8 multiplication of h max that we have to find. Fine. So it is negative 19.6 whole square will be equals to negative 19.6 multiplication of h max. So simple maths, people, this negative and this negative is cancelled out. 19.6 divided by 19.6 whole square, we are getting 19.6 as h max. So the value of h max will be equals to 19.6 meters. Again, very simple question, option B. Fine, chalo, let us move forward. What is this? When a bus suddenly takes a turn, the passengers are thrown outward because of, this is the example of inertia. It is the example, this entire phenomenon is the inertia, and it is an example of inertia in direction. But as you can see, acceleration cannot be the answer, speed cannot be the answer. If B and C is not the answer, the D is also not the answer. So we can talk about, see, this is an example of inertia in direction, but since it is written as inertia in motion, you can talk about this one. Okay, so that is why option A. It cannot be B, C and D. So it is the example of inertia in direction, so it will be A. Moving next, what do you think about this? What do you think about this? What do you think about this, people? See, a traveler while in the uniform, see, this word is very much important in this particular question. Uniform moving horizontally means the velocity is not changing, it is fixed. Getting my point? So it is moving, and the traveler while in It's while in a uniform moving horizontal train throws a ball vertically upward with respect to himself in the air, okay, the ball will return as what? So the option will be A. Why it is going to be A? Because of the uniform moving. Okay, if it is accelerated motion, then it is not. If it is accelerated motion, the ball will be forward moving backwards, everyone. Since it is an uniform motion, so it will be in the hands. Okay, good. Let us move to the next one. What do you think about this? If the distance between the two masses is doubled, the gravitational attraction between them will be what? So let us talk about this solution, people. And although it is a very simple thing, there is no any problem in that, because I'll teach you that also, do not worry. So we know F is equals to G, bigger mass, smaller mass, different R square. Distance between the two square. It is saying that when it is getting doubled, suppose that F1, nothing is getting doubled. G, bigger mass, smaller mass, divided by R1. Nothing is getting doubled. If it is getting doubled, in that particular case, it is 2R, it is getting doubled. Okay, it is twice the R1, basically. It is twice the R1. Fine. So if it is so, we will be finding out F1 by F2 can be written as, see, if it is so, we can write it down, G bigger mass, smaller mass by R1 whole square divided by G bigger mass, smaller mass by 4 times R1 square. This R1 cancel, this thing, this is cancelled. Okay, what is left out us? We are getting F1 by F2. We are getting F1 by F2. What we can get us? That is 4 by 1. Simple word, if I'm not mistaken, 4 times. Getting my point? That is, we can say F1 is to F2, it is equals to 4 is to 1. Now this is by the formula. This is by the formula. Let us talk about the very easy problem, no challenges question from my view. That is not, it is very simple questions. Fine. So this is by the formula. If we talk about a trick, not trick, because you know the formula, you know this. See, from this formula, we can find it out over here is, from the formula, we can say K F1 by F2, right? So it is moving forward. Fine, no problem. We are interested in F1 by F2, fine. So we can say that, suppose that if there is an F which is inversely proportional to the distance square, simple words, okay. So if the distance is increasing, which we are saying that it is getting doubled, the force will be decreasing. Getting my point? This is what it will be happening, everyone. There is no issues in that. Fine. Now, according to this, as you can see, F1 is to F2 equals to 4 is to 1. What we have to find is, we have to find out the change force, that is F2. So F2 will be equals to the 4th time of the F1 according to this. Okay, so the answer for this following question will be reduced to the quarter. I believe so. What do you say, people? What do you say? This will be the answer. It will be reduced to the quarter according to this. Please say na. Please say F1 is to F2 equals to 4 is to 1, that we all can understand. But what about the answer? People? Tell me. According to what will be the answer for this? Can we say that it is 1 by 4th? Option D will be correct answer. Fine. Okay, this is what it is there. We are not, see, our answer, it is f1 by f2, it is 4:1, but the question is saying the moment it is getting doubled, then what is happening? So it is talking about the f2. So if you want to find out the f2, you can clearly understand f2 will be equals to f1 by 4, that is reduced to the quarter. Option D. Fine. Chalo. Let us move to the next one. What do you think about this? The pressure at the bottom of the tank containing a liquid does not depend on what? So if we talk about the pressure, if we talk about the pressure of the fluid, everyone, if we talk about the pressure of the fluid, it is rho g h. Simple words. Okay. Rho is the density, g is the acceleration due to gravity, and h is the, you can say, depth. Fine. Acceleration due to gravity, it depends on that. Height, it depends on that. Area or density of the liquid, it depends on that. It doesn't depend on area of the bottom surface. Simple. That is option C, people. Okay. According to this formula, it doesn't depend on the area. Option C will be the correct answer for this. Okay. It says does not depends. Let us move forward. What is going to be the answer for this? Again, it is going to be law of conservation of momentum will be applicable over here. Okay, and we have to find out the answer according to this. Can anyone please let me know the answer for this following question? Can anyone please let me know the answer for this following question, people, please? Chalo. Let us solve this. A girl riding a bicycle along a straight road with the speed of 5 meters per second throw a stone of the mass 0.5 kg which has the speed of 15 meters per second. Getting my point? So mass of the, so now there is a girl, there is a stone, two bodies are given to you, and two bodies are moving with the two different velocities, that is 5 meters per second and this is 15 meters per second. Fine, no problem. Okay. We have found out the mass of the stone, that is 0.5 kg. Now the mass of the girl and the bicycle is 50 kg combined. Fine. What will be the change in the speed of the bicycle? That we have to find out. Fine, no problem. So if we talk about the conservation of momentum, everyone, over here, we can say the formula is momentum before collision. We can say momentum before collision will be equals to momentum after collision. If you can go with this, after collision, if you know the formula, this will be the answer. Before collision, stone, girl and bicycle, all the three things were moving same. Okay, they were moving in a same direction. They were same body. If they were same body, in that particular case, we know the mass of the girl and the bicycle, it is all about 50, and the stone, it is 0.5. These three things were moving with the velocity 5 meters per second. Fine, that is before collision. After the collision, what has happened? Now they have been separated. How they have been separated? Now the mass of the girl, including with the bicycle, okay, the mass of the girl, including with the bicycle, that is 50 multiplication of velocity of the bicycle plus stone, that is 0.5 multiplication of its speed, that is 15. Law of conservation of momentum, people. Simple, nothing is going to be done over here. Fine. What we have to find out? We have to find out the value of VB, that is velocity of bicycle. It is going to be 50.5 multiplication of 5 will be equals to, it is 50 multiplication VB, that is velocity of the bicycle, plus it is going to be half, that is 7.5, people. Okay, that is 7.5. 505, that is means it is what the punch 252.5 will be equals to 50 VB velocity of bicycle plus 7.5. That means 252.5 minus 7.5 will be equals to 50 velocity of bicycle. Velocity of the bicycle. This is what it will be there. Fine. If you solve this thing, you will be getting 0.5 cancelled. Okay. 7 to 545. 245 will be equals to 50 velocity of bicycle. Velocity of bicycle will be equals to 245 by 50. If you solve this thing, the velocity of the bicycle, I believe it is going to come 5 tens are 5 threes are 15, 5 fours are 20, 5 fours are anything 4 is there? No. Have I doing any mistake? 4s are 20, 445, 9, 4.9. No. Am I doing any mistake in this? So the velocity, the mass of the girl, what is the change of the speed of the bicycle? Fine, no problem. So velocity of the bicycle, that is coming out to be, it is 4.9 meter per second. But we have to find out the change, people. What we have to find out? We have to find out the change. Change means subtraction. What was the actual one? Actual one was 5 minus 4.9 will be equals to 4.9 will be equals to 0.1 meter per second square. Meter per second. That will be your answer. That is 0.1. Option B. I hope it is clear to all people. Okay. This is how you can solve this thing. Velocity of the bicycle. Now when the stone has been thrown. Okay, when the stone has been thrown, now the velocity is this. Okay, we want to find out the change in velocity. Before it was, now it is. Before 5, now it is 4.9. The change is 0.1. Moving next, what do you think? In verifying Archimedes principle, which of the following reading is not taken? Weight of the body, it is taken, as we all people know. Weight of the body is taken. Fine. Apparent weight of the body is also taken. Weight of the water displaced is also taken. So all of the above. The option is D. Simple. Okay. Every single thing is taken. Moving next. A piston of cross-sectional area, that is, this is given to you. Fine. Of an hydraulic press exert a force of 10 to the power 7 dyne. Okay. Of the water, cross-sectional area of the other piston supporting the mass. So we can understand from here, we know for solution for this particular types of question, people, we know few things. Solution for this particular type of question, people. What we know from here? We know from the Pascal's law, the pressure at the point 1 will be equal to pressure at the point 2. That means the force 1 divided by the area 1, area of cross section, will be equals to F2 by A2. Let us consider the F2, the second point, is the bigger one. Okay. If it is so, what we have to find? We have to find out the cross sectional area only. Force is given to 1. F1 is 10 to the power 7 dyne. Please do remember this. Okay, 10 to the power 7 dyne. We will be converting it, do not worry. And it is given as 100 centimeters square. It is given as what? 100 it is given as 100. Area is given as 100 centimeters square. Fine, no problem. When we talk about the F2, mass is given to you and we have to multiply it by G. Let us take it is 10. It is going to be 4 zeros divided by the area of cross section, that is 2. We are interested in finding out the value of A2, but there is a problem. What is the problem is we have to convert this particular force into dyne, which is given in Newton. We know 1 Newton will be equals to 10 to the power 5 dyne, everyone. Getting my point? If it is so, 10 to the power 5 dyne. If it is so, we can say over here is what? That is, it is in Newton converted in dyne. We can say 1, 2, 3, 4 and over here 5. So we can say that is, if you try to understand, we can say A2 na, this and this. We can say 2 into 10 to the power 9 dyne, everyone, divided by 10 to the power 7 dyne multiplication of 100 this. Okay, so you can say that A2 will be equals to 2 into 10 to the power 9 by 10 to the power 9. So A2 is equals to 2 centimeter square. क्या भाई 2 सेंटीमीटर स्क्वायर कहीं है? Two centimeter square. I cannot see the options, people. Can you please just look into this? According to me, it should be 2 centimeter square. But what do you think? I don't think so. I have done any mistake in this. 10 to the power 7 9. We have converted this. It is 10 to the power 5 and 4 zeros. It is going to be 9 only. Okay, A2 I have to find. It is going to be 100 centimeters square. So answer is going to be 2 only, I believe so. Might be some mistaken is there. Okay, the answer is going to be this. I cannot see any mistake in this, so this is what it is. Fine. Sure. If it is so, people, if you find out any mistake in this, let me know. Okay, I don't believe that there will be any mistake. So these are the entire thing, people. Okay, and there are few more questions that has been there for you. Okay, I request you all to please solve it down, and we will be meeting in the next session. Till then, if you haven't registered yet, please register, everyone, and after that we can. Please do like, comment and share the entire session if you liked it. Okay, you can follow us on the Instagram, subscribe the channel, Telegram, and our, what do you say, our app also is there. So thank you everyone for joining. If you find out, thank you everyone for joining this session. Thank you. Bye. See you all. Have a nice day. Thank you.